let's look at some implementations of the page replacement algorithms. These are not very important coming for the coming to the gate point of view, but then maybe if you are planning to write an algorithm or implement it, in general what happens is in some colleges they have some good assignments. So while especially they'll ask you to implement these algorithms on some open source operating systems like Minix. So especially if you are looking at some algorithms, implementation point of view from the operating systems, then these are important. But anyway, for Gate, the implementation part is not required, because we are not going to write code in operating systems in Gate. They just want to test your concepts. But let's look at this. So these are the main important page replacement algorithms. The first most important one is optimal, and I told you that optimal algorithm can never be implemented practically. The reason is we can never look into the future, right? And we can never know what is the sequence of page requests which will be generated during the execution of a program unless you execute it, isn't it? Therefore, since we cannot look into the future, implementation of optimal is impossible. And then coming to this not recently used, so there are various other versions. Okay, so one interesting algorithm is not recently used, which means among all the pages we'll see whichever is the recently used page, and then we try to let it be in the main memory, and whichever is not being recently used we try to replace it, and that one is called as not recently used algorithm. So how does it work is, watch it. See, let us say the pages are 0, 1, 2, 3, 4, 5 like this, right? Pages, all these pages are there. Just assume that we have all these pages in the page table, right? And some of them are in the main memory. Let's say all the pages are in the main memory, right? Then what we do is we fix some interval of time, and this interval is just configurable. So generally they'll take a clock. So from here to here, if you say that it is 1 clock, then in this 1 clock, whichever pages are referred, all those pages will have a special bit called as referred bit. In the page table, I told you already that every page table entry contains a special bit called as reference bit, and that bit will indicate whether that page has been referred or not, right? Then what we do is we are going to have this referred bit, right? And then if the page has been referred in this clock, then we are going to make it 1. If the page has not been referred in this clock, then we are going to make it 0, right? Like this. So if this is the scenario, then what it implies is the page number 0 has been referred and page number 1 has not been referred in the last clock. Got it? So this is how referred bits are used. And let us say now I have to replace these pages with a new page. Then what I do is I am going to replace the one which is having 0 in the reference bits, right? Either I'll replace 1 or 3 or 5, right? That is how not recently used is implemented. Are you following this? So what I mean to say is, in 1 clock we shall see what are the pages that have been referred, and in 1 clock we may get any number of memory requests. In all those memory requests we will see what are the referred bits. So what we do is we have a temporary variable in which we store initially the reference bits, temporary array, and later we'll copy this onto this one, which means temporary reference bit will be maintained, which will maintain a temporary reference bits for all these one, right? Whenever they are referred, it will be made 1 like this temporarily, and at the end of the clock this entire temporary variables will be copied into the actual reference variables, right? Therefore we'll keep this up to date. So at the end of every cycle we'll know what are the pages which have been referred in the recent clock and what are the pages which are not been referred in the recent clock. Then depending on that we'll replace it, right? And there has been one extension to this, which means we could even extend it a bit further and make it somewhat efficient. So what we do is, along with the reference bits, we'll even maintain a modified bit like this, which means if modified bit says that let us say it is like this. So modified bit says that the page has been modified after it has been loaded. So whenever a page has been modified, we generally don't try to replace it, because the replacement taken, the replacement time or the page fault time for replacing a page with a page which is modified is generally more, because whenever you have modified any page in our main memory, and when we try to discard it, then we are supposed to overwrite it on the existing secondary memory and then get the old page there, right? So because of this movement, the page fault is going to take a lot of time, right? So whenever we have a choice, right, so we are going to maintain a modified bit also. I think you remember that modified bit, which is also sometimes called as dirty bit. Dirty bit indicates whether a page has been modified or not after it has been fetched. In case if it is modified, and in case if you are trying to replace some other page in the place which is in which at which this one is present, we are supposed to write it back and then get it. Okay, see what I mean to say is this one. Let us say there are various frames, and let us assume that there is a page number 1 here, right? And now it has been modified somewhere here, right? So it has been modified. Now in this same frame, if you are trying to get, let us say, some other page from the process, if you are trying to get it, you are supposed to write it back in its own place. Let us say this is 0, this is 1 place. You are supposed to write it back and then read it. In case if you are trying to replace, you are trying to get this page into some other page where the modification is not there, then you can directly overwrite on that. So that is why the time taken for the page fault when you are trying to replace the page with a page which is modified is generally more, because of this rewriting back. This is writing back, right? Write back. So when you have to write back a modified page, it is going to take more time. So what we generally do is, if we have an option that you can replace between two pages, one page is modified and other page is not modified, you generally go for the one which is not modified. So you can do a minor modification to this example to improve the performance. So what is the modification is like this. Let us say we maintain these 2 bits for every page, right? Then what are the various combinations? 0 0 0 1 1 0 1 1. Now let's talk about each one. Now this 1 1 combination says that the page whichever you are looking at has been referred and the contents have been modified. Therefore, since it has been referred recently, we are not going to replace it, and moreover we have even modified the contents, so replacement cost is more, the replacement time is more, so we will not replace it, we'll choose some other page for replacement, right? And what about this one? This is saying that the page has been referred. The page has been referred recently in the last clock cycle, but it has not been modified since it has fetched. See, a reference bit says whether it has been modified or not in the referred or not in the last one previous clock cycle, but modified bit says whether it has been modified or not throughout its lifetime, right? Therefore this referred bit, this 1 0 indicates that the page has been referred but it has not been modified, right? So since it has been referred, we are not going to replace it, right? So in case this one says that the page has not been referred but it has been modified. Oh, how is that possible? How can a page be not referred, but how could it be modified? It means that the page is not referred in the last clock cycle, but it has been referred in earlier or previous clock cycles where it has been modified. That is the meaning of it, which means initially a page will have 1 1 whenever it is modified, why it has to be referred, and later after some time, after some few clock cycles, if the page has not been referred, then what happens is its reference bit will become 0 and modified bit retains the same value 1. So that is how we get to this case. Then what about this one? A page is in the main memory and it is saying that it has not been modified and it has not been referred. How is this possible? If a page is brought into the main memory, right, how can you say that it is not being referred and not being modified? It is possible because it has been referred very long back, but it has not been referred recently. So the disadvantage of using this reference bit is it will just tell you whether it has been referred in the recent clock cycle or not. Okay. That is the disadvantage of this. Anyway, now if we have four options like this, you have 4 different classes. Which one do you go for first? The first one to be replaced, the best possible one which has to be replaced is all the pages which belong to this class, which means now we are dividing the entire pages into 4 classes. What is one class? Not referenced, not modified, not referenced but modified, referenced, not modified, referenced, modified, right? So the first best class, best page for the replacement is 0 0. Why? It has not been referred and it has not been modified, isn't it? And the next one which is suitable for modification is this one. Why? It has not been referred recently, therefore we think that the recent past will actually be equal to closest future. That is the assumption, right? Which might not be true, but then our algorithm follows that. The second best one to replace, for the suitable one for replacement, is this one, and the third best one is this one. See, you might get a doubt that if a page has been modified, why do you want to take it? Because our algorithm is based on the recent reference. It is not recently used algorithm. It is not modified algorithm, right? Are you getting this? The algorithm is not modified algorithm. It is not recently used. That is why we are only based on recent bit. Even though this is going to give you some more extra cost, still this is the second one which has to be replaced first, right? And what about this one? 1 0. What does it say? It has been referred. If it has been referred, it should not be replaced as of now if you have other options, right? Therefore this is the third best page to be replaced according to this algorithm, and this is the last best page to be replaced, which means if you don't have any other pages of these classes, then only you go with this. If there is a page which is available like this, replace it, or otherwise you go for this, otherwise you go for this. Only in the worst case you are going to replace a page which has been referred, which has been modified. Got it? And now let's see the next one.